Welcome to another tutorial. So we stopped at this question whereby we are supposed to move to the next part, whereby this part is what really is it really talking about? We were to move to the part where we are talking about the specific heat capacity, and then you are supposed to state what do we mean by the term specific heat capacity. So in that case, when you are asked during your May-June exams, you are going to say this is the amount of thermal energy required to increase the temperature of a substance by 1 degree Celsius. So you have to be very specific. That is the amount of thermal energy required to raise or increase the temperature of 1 kg of a substance by 1 degree Celsius. Then you are told here a question whereby you're supposed to use density to calculate the mass. We understand that density is equals to mass over volume. Yes. And then now the mass is calculated in kg here, but you need to remember that the density was given in kilograms and then the volume is given in centimeter cubic. So meaning we are going to divide by a million in order to convert the centimeter cubic to meter cubic so that you can be able to multiply by the density for us to get the mass to be 0.5 kgs. So if you are new to ProfLearn YouTube channel, consider subscribing so that whenever I'm going to upload the third portion of this tutorial, you'll be notified. So you need also to learn on how to work out the energy when you are given thermal energy, when you are given different parts. Of course, this concept here about latent heat of vaporization and latent heat of fusion is not really very clear to be done by 2025 students, but it is very good for you to know what is supposed to be done. In the event an examiner decides to test that concept, you know exactly what to do. So remember, thermal energy is given by the formula mass times specific heat capacity times the temperature change. So we are told that a bowl containing 500 centimeter cubic of water at a temperature of 5 degrees Celsius, the bowl is placed in a freezer. So meaning the temperature will decrease from 5 degrees Celsius to 0. So which amount of thermal energy will be given? It will be 0.5 times 4,200, which is the specific capacity of water, times the temperature change from 5 to 0. That amount of heat will be given out. Okay. It's very cold here. I'm just having a cup of coffee just to raise a little bit the thermal energy of the body. Yeah, it raises a little bit the thermal energy. So also we are told that when the bowl is removed, the temperature of the water or the ice, it becomes negative 18 degrees Celsius. So meaning the amount of thermal energy supplied for all the amount of water to be converted to ice is going to be 0.5 times the latent heat of fusion, which is going to be 0.5 times 3.3 times 10 raised to the power 5. Then plus. Now, when ice now is dropping its temperature from 0 all the way to negative 18, so the temperature change there will be 18. So we are going to use the mass of ice times the specific capacity of ice times 18. So if you work it out, you are going to get your answer equivalent to 194,400 joules of energy. Another concept that you really need to understand is about energy resources. You need to understand how to define renewable energy and non-renewable energy with their examples, advantages of renewable energy, disadvantages. You need to understand types of resources, of course, and then how to define them, and then different examples. So in this particular question 8, we are supposed to state 2 energy resources for which radiation from the sun is the main source. So this is solar energy. Solar energy, if you take solar panels, they will absorb the energy from the sun, and then it's used to warm and heat water. But wind energy, because the radiation or radiant heat from the sun hit the ground or the earth surface at different uniformity, and then it means that different regions of the earth are going to be at different temperatures. So regions where the sun hits most, or there is a lot of thermal energy, that air around there will become less dense, right? It will rise up. Then dense air will just move to replace the less dense air that has actually been risen. So meaning we are going to have now wind flowing. So another concept you need to understand also is about thermal, besides thermal energy, besides energy resources, you need also to know how to calculate kinetic energy. And we know kinetic energy is equal to a half mv, a half times the mass times the speed squared. And also you need to remember the concept of gravitational potential energy, which is also mgh. Yeah, GPE is equals to mgh. So in this case, we're told the wind turbine is used to generate electricity, and the useful output from the turbine in 1 second is 6,000 joules. The kinetic energy of the wind hitting the turbine in 1 second is 11,000 joules. Then we are supposed to calculate the velocity of the wind hitting the turbine is this. Show that the mass of air is approximately 550. So meaning you are going to use the formula kinetic energy equals to a half mv squared, as stated here in the formula. And then you are going to substitute kinetic energy is 11,000. Then we are going to make m the subject of the formula in this case, so that we can be able to say our answer becomes 554, which is actually rounded down to 550 kgs. We are supposed to calculate efficiency. So another concept that will be very, very key in this coming May, June exams is the concept of efficiency. Do you know how to calculate efficiency? Of course, efficiency is useful power output over the total power input times 100. That's exactly what you're going to do at that particular point. Sometimes you'll be given about question to do with disadvantages and advantages, and that's basically what's forecast here. The tidal energy and wind energy are both renewable energy resources. Renewable energy resources are those energy resources that you can never finish. They can never be used up. They can never be depleted. But non-renewable, they can be finished up. Yeah. And also remember those that contribute to global warming. So you need to be very, very careful reviewing all the areas, so that when it comes to the main exams, you are able to reproduce their concept and apply that in paper 4, right? So suggest one reason why tidal energy is more useful than wind energy. Remember, wind energy is not reliable because it's quite unpredictable. You cannot be able to have a continuous flow of energy, because wind can sometimes flow at a very high speed, and after a few seconds it disappears. So, but tides, they're kind of predictable. So you're going to base your answer on that. So another concept you need to understand is the concept of evaporation. How does evaporation cause cooling? And remember, evaporation takes place on the surface, while boiling takes place in the entire liquid. Evaporation takes place at any given temperature. Boiling takes place in a specific amount of at a specific temperature. So you need to understand the differences, and also you need to know how how evaporation enhances all causes cooling, because evaporation is a process by which energetic water molecules or liquid molecules escape from the surface. Those molecules which have high kinetic energy, they escape to the surrounding. The process, the net molecules, or the molecules left behind, they have less kinetic energy, so they have also less thermal energy. Then explain, as water is heated, the pressure of the gas inside the cooker increases. How does water molecules result to pressure? remember the water molecules, as you increase the temperature, kinetic energy increases. And this kinetic energy of the molecules enhances the collisions on the walls of the cooker. So this result force exerted on the walls, and force per unit area is pressure. So that's why we are saying as temperature increases, kinetic energy, kinetic of gas molecules increases, and the molecules collide more frequently with the walls of the cooker, exerting a greater pressure, exerting a greater force, and force per unit area is pressure, and that explains why. We are having a scenario here where we have a portable shower here on a campsite, and the bag is filled with water, and then that black bag is used to warm the water. Why is it painted black? This is the concept of this is the fact that black surfaces are good absorbers of radiant heat. So the choice of the black painting is due that black surfaces are good absorbers. So they are going to absorb more radiant heat from the sun, and they're going to warm the water. What is the disadvantage? Remember, this will only work when there is sun during the day, but at night when there's no sun, it cannot be able to work out. So this is not very reliable, right? Solar energy is a renewable energy resource. Which are the other examples? We have wind, we have geothermal, we have tides, yeah, and many others. So check on that as you are revising. During the day, the sun shines on the shower bag, and some of the energy in the infrared radiation from the sun transferred to the thermal energy store. And then we have, we are told only 60% of the incident is absorbed. Then the mass of water in the bag is 40 kg. The specific capacity of water is 4,200 joules per kg by degree Celsius. Then we're supposed to calculate the thermal energy incident to the shower. So first we were supposed to calculate the temperature change. That was 43. Temperature was 10 degrees Celsius. It increased to 43. So which means the temperature change here is at 3 degrees Celsius. But we know that thermal energy is MC change in theta. So the mass is 40 times the specific capacity 4,200 times 3, and that translates to 55. That is 5,554,000. Then now, since we were told that only 60% is absorbed, so since this is the amount of heat that is used to warm the water, so it means this is equivalent to 60%. 60%. So how do we work out the 100%? So we can be able to put that in, and we shall have the 9,240,000 joules of thermal energy that was applied, but only 60% of that was absorbed. So I believe that's okay up to that point. So the other concept that you really need to remember, to review, and to go through is the concept of refraction of light. Remember, refraction is the bending of light, or bending of a wave as it moves from one medium to another at the boundary. But diffraction is a spreading of a wave around a boundary all through a gap. So you need to understand that. And under diffraction, when the wave is moving through the gap, if the size of the gap is equivalent to the wavelength of that wave, is going to undergo maximum diffraction. So that will be very key. So what we need to remember in this case, under refraction, in a dense medium, the wave is going to slow down. So speed is going to slow down when it enters into the glass block. But the wavelength also is going to become smaller, but the frequency is going to remain the same. So you need to remember also this wave equation. And of course, for you to work out the refractive index, you are going to use the formula n is equal to sine I over sine r. In this case, we have our sine I here and sine our refractive angle of refraction at this point. So it will be sine 45 divided by sine 30, so that we can be able to get our answers 1.4. Now, for you to work out the critical angle, to find the critical angle, remember the relation between the refractive index and the critical angle is that sine C is equals to 1 over the refractive index. And then if you work it out, you are going to get your answer being equivalent to 45 degrees. Yeah, moving down, you are supposed to state two uses of optical fibers. They are used in hospitals as endoscope. They are inserted into the mouth through the mouth into the stomach so that you can be able to see maybe the walls of the stomach in hospitals. But also they are used in communication to pass information, to pass data. And the advantage to this, it can be able to carry a lot of data. And it also has very little resistance. Data is not lost in that process. So you need to understand that. And in the event they tell you to draw how light travels through, it goes like that. To move this way, it undergoes total internal reflection. Yeah, at this point now, when that light reaches there, it's reflected at that point, and then eventually that light gets out like that. So that's basically what we shall talk about. So another concept under light waves you're going to learn is how to construct ray diagrams on lenses, and also the concept of explaining characteristics of the waves, the images formed by lenses. So for in this case, what you need to understand from the object here, this point, one ray will move parallel to the principal axis. That ray, the moment it reaches the lens, it will pass through the principal focus. And another ray will run straight from the object through the center of the lens and deviated like that. So you can see these two rays will never meet anywhere. They are diverging, diverging and diverging. So the only way we can have our image is by extrapolating the lines backwards, and the image is going to be formed at these given points. So this image has been formed by visual rays. This image cannot be formed on a screen. So it's called a visual image. But when you look at it, it's upright, it's magnified because the size is bigger. So those are the kind of characteristics that you are going to look at whenever maybe you are asked a question in an exam. So another way you can be asked here is a question to do with the distance. Maybe you can be asked to measure the distance. So you are going to put your ruler, then measure the distance, IY, the distance IY, yeah. Okay, measure the distance IY along the principal axis to the center of the lens. So you'll measure this distance up to that particular point. So basically, you are going to use your ruler there in order to measure the distances. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials on this, you'll be notified. Also, I'll be doing more concepts in additional math, and also we shall talk about practicals, how to answer practical questions here. So we have every reason as to why you need to subscribe to Proflan. Also A-levels, you'll be going for A-levels, and Proflan would be a good place for you to be. Talking of dispersion of light, when light is incident to a prism, there is dispersion, separation of into different colors. So what we need to understand that blue light has a shorter wavelength, so it will diffract more. So if we have green light, it will follow that path, but blue light following the same path at this point, it will undergo a greater refraction. Yeah, it will bend more, and at this point also it will bend more. So for you to finish the way blue light will be able to travel, that's the way. But the concept is blue light has shorter wavelength, so it will refract more than green light. So the next part that we are talking about is charges, electrostatics. Remember, light charges repel and light charges attract. When a plastic rod is uncharged, when the rod is wrapped with woolen cloth, the rod becomes negatively charged. explain in terms of particles why the rod becomes negatively charged. The rod becomes negatively charged due to friction. And this happens when electrons move from the cloth to the surface of the rod. So meaning if we are talking of a piece of cloth like this, which is having positive and negative charges, and then when a rod is wrapped on this, the electrons will be transferred to the due to friction. So the piece of cloth is going to remain positively charged because electrons has been removed from it. We have a negative charged metal sphere, and state what's meant by electric fields. In case they ask you such question, just respond by saying that this is the region where electric charge can experience a force charged near the sphere, a negative charge near the sphere. This will experience a repulsive force. So it will move away at a very high speed. It will move away at a very, very high speed. Also state the concept of refraction. In this case, the examiner gave angle X. And remember, the angle X is between the oil and the incident. So angle of incidence is the angle between the incident ray and the normal. So that is the trick that you have to remember. So if you are given this angle, that is a trick. So you have to take 90 minus 56, you get 34, and that's the angle of what? Incidence. Then you are supposed to calculate the angle of refraction when the refractive index is 1.47. So to do that, you are going to say n is equal to sine I over sine r. Substituting that, we are going to get our angle equivalent to 22 degrees. And the approximate speed at which light moves in air is 3.0 times 10 raised to the power 8 meters per second. Don't forget that. Calculate the speed of light in oil. We are just basically here, the examiner is testing. Do you know that refractive index is also calculated by this formula? Speed of light in a vacuum over the speed of light in oil or any material. So that's what the examiner was testing. Basically, that's where I want us to stop in this particular tutorial. Next video, we're going to talk about electricity. Then we shall talk about electromagnetic induction. We shall talk about transformers and get to see how do you approach such kind of questions. So if you are new to Proflan YouTube channel and if you have not subscribed and you are going to sit for the May June exams, you have every reason to subscribe so that anytime I'm going to upload the next tutorial, you'll be notified. See you in the next video.